let's consider two charges, Q1 and Q2. And we wrote down Coulomb's law, R hat 1, 2, and the force on that charge is our constant K, Q1, Q2 over R12 squared, R hat 1, 2. Now, one of the issues in applying Coulomb's law is this is an abstract expression. And we'd like to even make it a little bit, one more version of it. Let's write the vector R1, 2. This is the vector from object 1 to object 2. We know that the unit vector is equal to the vector divided by its magnitude. And the magnitude of that vector is what we're denoting as R12, this distance. And so we can rewrite Coulomb's law in the following form. F12 is K, Q1, Q2, vector R12, divided by, now this looks a little strange, R12 cubed. This is not a 1 over r cubed force. It's still the 1 over r squared force in magnitude because that extra factor of r is embedded in that vector. So these are two different ways of abstractly expressing the force on object 2 due to the interaction between these two charges. Now, one of the issues, though, in problem solving is we want to get a vector expression in a coordinate system. And so what I'd like to do now is show how we do that. So let's look at this same problem. First, we have Q1 and Q2. So we have two charges. And now let's choose a coordinate system. So we're going to put, this is Q1. It's going to place Q1 at our origin. This will be plus x, plus y, I hat, j hat. And what we'd like to do is express this force in terms of our coordinate system. We have these two vectors, r1, 2, and r hat 1, 2. Now, if this is the position x2, and over there is y2, our charge 2 has a coordinates x2 and y2. And now what we can easily express both the distance using the Pythagorean theorem and this vector r12. So let's write these out. r12 is simply the decomposition. So we can think of that as the sum of this vector plus that vector. And that's equal to x2 I hat plus y2 j hat. And the magnitude of this vector by the Pythagorean theorem is simply x2 squared plus y2 squared to the 1/2. And now we've expressed all the terms that we need in this expression for Coulomb's law. And so the force on object 2 is the constant K, Q1, Q2. Now here's where this is to the cubed. And what we have is x2 squared plus y2 squared to the 3/2 power. And that's because this is to the 1/2 cubed. And now we have the vector x2 I hat plus y2 j hat. And so we've now expressed the force on object 2 in terms of our Cartesian coordinates.